Yeah. So, dear student, continuing from the last chapter, which is about the Naive-Bayes algorithm, and we calculated the probability for yes with the conditional probability. Now, see if we could calculate for the no. So, similarly, we will calculate about the no. So now we can see how many no's are there. So there are like six no's, and in the six no's, how much we have it. Yeah, so how many cows are there with the no? Two cows, and with the mediums we have like with the no we have a two like medium, and color one only, right? So yeah, so color like color with the which color, like black color. Yeah, so the black is only like one, and then and the total no we have 6 by 14. By this way we find it. So for the no, the conditional probability is 0.0079, while here is 0.02, so it's more higher, right? So we know that for probability of yes slash test plus p slash no slash test equal to 1, so we normalize the results, right? So when we normalize the results, so for that one, what we have it. So after normalization, by applying some mathematical function on that one, we get it. So for yes is like 70%, 71%, and for this no is we have like a 28%, right? So it has been now normalized, and here are like yeah. So we see that for yes is more greater, so the prediction that we can pet this animal is yes, yes. So. So here are some more examples, like it will be like understanding the Bayes rules. D is equal to data, H is equal to hypothesis. Just like rearrange this one, the same point probability on the both sides, we have it. And then we have a prior probabilities, likelihood of this one, data evidence, marginal probability of the data, posterior probability. At the end we get it. These are like some rules regulations for Bayes rule. Yeah, there is another example. Similarly, we can also do what we did for the cows, okay, and pet animals, and then we can do it for the tennis play, yes or no. Yeah, so similarly, here is like the product function. Yeah, so the not the cross function. You can see a cross function. Yeah, and by this one we can get the maximum argument from that one, and estimations can be done over here by using this formula. Yeah, so this is very good example. I think I would like to explain that for you, and then if you can, how many years are there? So you can see if you count it, so there are almost 9 years, most probably. One, two, three, four, five, six, seven, eight, nine. Yeah, and how many nodes are there? Two, four, five. Five nodes are there. Yeah, and similarly for this one, for yes, we can see sunny, cool, and high, and with the yes probability is 0.053. Again, it is higher, and for the no, we have 0.206. If you round it about it, so even still, I know. I think for no is higher because it's 0.02 is higher, and for yes it is lower. Yeah. So we should not play the tennis according to this structure. Yeah, clustering K means again like yeah. So in the chapter 7, like if there is some part of the clustering as well, according with this one. So as we know that clustering is basically is non-supervised. Here we don't know how many cluster will be made over here, and it's unsupervised learning. And you can see over here again given a set of objects like where it has been placed, and you can make groups of it according to the similarity with respect to the shape, with respect to the distances, depending on that one. So, and this is called intra-cluster distances, and it's called intercluster. So intercluster means between the two clusters, intra means between the 2 points inside a cluster. So we have like different kinds of clustering: client clustering, product clustering, and data clustering. So what is a client clustering? Basically, client clustering is a technique of organizing individual according to their behavior, habits, preferences, values, social class, geographics information, and demographics, among the others. In a practical way, this technique goes beyond the segmentation because it considers more intangible variable in the group organization framework such as mindset, opinion, and context. Through clustering, companies optimize the quality of the messages they send to the public, such as product promotions. Yeah, so that is like how you can custom how you can cluster your clients. Some clients are high value clients, some are low value clients, some are like medium, average, Yeah, so this is one of the good examples, and sometimes you can see selling the product to the target audience can lead you to earn more money. Products one, yeah, you can also classify the cluster according to the products. Like for example, if you have the shoes, you have the electronic devices, you have the clothes, you have the bags. Like you can classify accordingly. When it comes to a retail and e-commerce product are heart and soul of the business. Major challenges like we have it based on the cluster data, either quantitative or qualitative, which into take account such as an average income in the region, climate, consumption habit, tourist profile, among others. It can be possible to predict which clothes will sell the best for the franchise. And this allows logistic to send customized shipment to this maximize sell. And third one is, yeah, so last time yeah, data clustering. So I hope you have the data clustering here as well. So k-mean is basically is kind of classification of the objects into different groups, or more precisely, the partitioning is a good word for the data set into the subsets, so that data in each subset ideally shares some common traits, often according to the some defined distance measures. So clustering, we have different parts like hierarchical clusters. In that one, we have the agglomerative, which is called bottom-up approach, divisive, which is the top-down approach. And partition clustering, we have the k-means derivative, we have fuzzy c-means clustering, and QT clustering as well. So, these finds the successive clustering using the previously established clustering. So, agglomerative clustering begins with each element as a separate cluster and merge them into a successive larger cluster. So, it's called kind of like inclusive clusters, or recursive cluster, you can say. Divisives, top down. Divisive begins with the whole set and produce to divide into the successive smaller sets. So this is top down approach. Yeah, fuzzy C means clustering, and you have QT clustering algorithm as well. So we will discuss at its approaches. Common distance, so as I told you, Euclidean distance and Manhattan distance are there. So yeah, so the difference between is the square root. So Euclidean doesn't have a square root, and Manhattan has as a square root, and it's also called the taxi cab norm, or one norm is given by. So this is in Manhattan, in New York, the taxi use this formula kind of. So it is just similarities or derivative from that one. Yeah, so you can see here how the Euclidean works. So this is simple example we already discussed in the previous lectures. Okay, so the maximum norm is given. Mahalanobis distance also correct data for different scales and correlation in the variable. Inner product space, the angle between two vectors can be used as a distance between measure when clustering high dimensions. Hamming distance, sometimes edit distance, measure the minimum number of substitutions required to change on number of into another one. Yeah, so these are different distances. So graphically you would understand it more better. So Euclidean is this one. Cosine distance is depending on the angle increases, distance increases. This is the Hamming one. Hamming one means for dissimilar is 0 or 1, I think. Yeah, so for similar is 0, for dissimilar is 1. Yeah. So yeah, so this is my formula how I do the exclusive or so this dissimilar means 1, the rest are become 0. Manhattan, yeah, Manhattan is just like it is used by the taxi in New York. So because it's not like a displacement. Yeah, in the Euclidean it's a direct displacement, but in Manhattan you cannot have the displacement because sometimes roads are blocked. Yeah. Minkowski, yeah, Minkowski is also very popular as kind of a Japanese name, and you can see the distances between those two. So if we have p equal to 1, p equal to 2, and sometimes p equal to infinity. And then the another one is called Chebyshev distances. This you can see from the figure. Then we have jacket distances, like with the union and intersection. So intersection divided by the union we call the jacket distances, and then we have the Haversine distances, it's mostly used in the galaxies, and Euclidean dice one distance. So here we have clear with the multiplication of the two, and A and B are non-intersective. So this was about the distances, and then we have the k-mean algorithm cluster based on the attributes of k partitions. and expectation maximize algorithm for the mixture of Gaussians in both attempts to find the center of the natural cluster of the data. It assumed that the object attributes for the vector space, right? So this is like, the distances for the jagged one. Okay, so here that you can like you can find like in your school the like maths, you can find that how it works. So I will just go jump into the main crux of the algorithm, that how this algorithm works basically. Yeah, so the distance is number of clusters k centroid and distant object to centroid, grouping the based on the minimum distances we have it. And then you have this, you can see clear data clustering in the blue and the orange color. How many clusters you have? This let's say distinctly two clusters. Yeah, and here is the sixth cluster. If we differentiate with the shapes, here are the four clusters with respect to the shapes and colors. Yeah, so a clustering is a set of clusters. Yeah, so important distance between the hierarchical and partition. So hierarchical clustering is the division of data objects into non-overlapping subsets, while hierarchical is the nested one overlapping. So I would like to show you some pictures. Might be, yeah, this is very good one. Yeah, so I taught this in my data mining course, and it like it gives a good understanding of the different types of the clustering, like traditional hierarchical clustering. So points within the points. Non-traditional means the points are separate to each other. There is no linking. Traditional is like a dendrogram, and this is non-traditional dendrogram. Yeah. Exclusive versus non-exclusive, and fuzzy clustering we have it. In fuzzy clustering, a point belongs to every cluster with some weight from between 0 to 1. So this is more probabilistic. As I told you, like Luthri Zada here, he works on this one, that it's not necessary only to be focused on 0 and 1. There are some points between 0 and 1, like 0 0.1, 0 0.2 till 0 0.9. So why not consider have some threshold values? Weight must be sum of 1. Yes, of course, all probability is 1. Probabilistic clustering has similar characteristics. And then we have a partial versus complete. In some cases, we only want to cluster some of the data. Yeah, in non-exclusive clustering, point may belong to the multiple clusters, like can belong to the multiple classes as well. Yeah, so we have well-separated cluster, prototype-based cluster, contiguity-based cluster, density-based cluster, and any cluster described by some objective function, as we did in support vector machine. This is well separated clusters, prototype based clusters. You can see from the figure. Contiguous vector, some are like somehow like inserted into some other clusters. Density based clusters is a bit different than that one. So cluster is a distance region of points which is separated by low density region from the other region of the high density. So here is the density, but here is not the density as matter. Here is a set of points that's closer to one another, and that point is not in a cluster. But here is a density base. So some density are more and some density are less. You can see the color changes. And clusters are irregular or intertwined, and when noise and out are present. So types of proximity of distances we have it. So there are like other features like noise, how to remove the noise. We have a k-mean and variance, hierarchical and density-based clustering. And apart from that one, we have partition clustering approach, number of clustering approach. So here you can see, yeah. So so these are like different kinds of like clustering we have it. So just like to quickly go through different cluster, and you can see the centroid is like moving from one place to another depending on the clusters. Yeah, and then we have some original points, and again some iterations we have it. So yeah, I will discuss this more in detail when I am discussing the clustering algorithm. Yeah, so just like I'm quickly moving through this one because it was linked to the Bayes algorithm, and then you can have this more information on that one. So thank you very much, and I hope that you have learned a lot from this one, and it will be a good ending for you. Thank you.